Your AI writes code that looks great but breaks your rules. It ignores your architecture and invents the pattern that doesn't exist. Does it sound familiar? Well, then you are at the right place. I'm Nilay Parikh, and I've spent 20 years in big tech and startups. Today, I leave LocalM and Airbusum, where we build advanced AI for software development. This particular course, Context Engineering for Copilot. In this course, we will learn how to turn Copilot from a generic assistant into an expert on your specific project. We'll cover 7 key ways to customize it, including instruction, prompt, agent skills, MCP hooks, and plugin. We'll start pretty much blank, so everyone can start along with, whether you are in the mid of your journey or you're just about to begin your journey with the AI-assisted programming. By the end, you will have a good professional understanding how to make Copilot understand your entire code base. You will learn how to build project-aware AI and avoid the common mistakes like instruction bloats and avoiding the hallucinations. Today, it's a first lesson. It is going to be simple in terms of execution. We will give exact same prompt to the same repo twice, one with context and one without. But don't take it as a mistake. We will go under the hood and understand how coding agents behave differently in both perspectives. That will help us to understand the importance of context. And the understanding of behavior will also help us to explore the other areas that we will go in next lessons. So this is a very important lesson. Please don't ignore. You will see why context is the only, and it's not only, one of the most important way that stops AI from wasting your time. Let's start with the big question. Why does AI-assisted coding actually fail? AI coding tools are the strong generalist, but they miss what's specific to your project unless you teach them. Without lasting context, they'll pick wrong framework, wrong naming, wrong constraints. They aren't just the modern failures, they're context failures. Let me show you with the real data. We will run this example on VS Code. However, just to summarize before we get into the VS Code, we gave Cloud Haiku 4.5 the same coding task twice. Implement a menu review escalation feature in the loan app. The only difference was the context. With the context, the model found hidden spec within 15 seconds. Planning all 14 requirements and made a tight 3.1 kilobyte batch, touching just 2 files as exactly it needed. It scored 14 out of 14 on all the assessment criteria we have set. We will walk through those assessment criteria on code quality as well. Without the context, the same model been entirely new escalation subsystem, functional, working, but a lot of unnecessary code, 5 new files, a new database schema, new queue contracts, and almost 34.8 kilobyte of confident well structure, but not so good code. The reason why it is not so good, because it's hard to maintain. If the code bloats at this rate, most likely in a couple of months, the application become unmanageable. It scored 4.5 out of 14. Produced more code with the confidence, but it couldn't be more wrong. Let's quickly go into VS Code and try to understand how it worked. So we are in the VS Code. Here I have got 2 examples in front of me. First I will run simple task. This is a demo. So in this Python file, you'll see that it's just a wrapper of GitHub Copilot CLI. All it does, it set up the project on its own, remove the old project files, and ensure the correct GitHub CLI command with the correct prompt. It doesn't do much. It does not interfere in how it works. But in a simple way, it will generate at the end of the day logs and a change. So now we are running, so change file should be deleted. Yes, exactly as we anticipated. And towards the end of it, it will produce this results as what it changed and what are the logs. It will dump the complete GitHub Copilot CLI logs. Before we get into the results, this is the last run, and I have validated the session efficiency that you already saw in that slide. A short period of a duration, the tool call almost half, and most importantly, the context it used. The token usage was almost 1/3. In some cases, in Fusion lesson, you will see even the 1/5 of the token usage. A lot of time, we see this problem. The tokens run out very quickly, and the user is getting a call limit or the rate limit. And that is because not just its models are hungry, or the application is too token consuming, to application consume too far tokens. No, it is most of the context, because the thinking tokens are generally wasted to actually traverse and understand the code base during the request. So the contexts are actually the one who make not just your process faster, but also make cost effective. Now we got already the with the context finished. So let's see what with context look like. We got our files, the demo patch. It got almost 102 line of demo patch. You can see two files been changed. And if you see the change file, that precisely 2 files has been changed. While the other one will time out, and not because it's failing, but because I want to restrict the time during this lesson. However, it will also generate the change log. So let's wait until they get generated. But in a simple way, what it helps to understand is one is a precision engineering versus other one is just a functional engineering. The both approaches has different value to deliver. The one can provide quick prototype and an application that doesn't require a further changes or maintenance to be. But if you are developing an enterprise application where the iterativity and a further development support is essential, then contexts aren't optional. Because there is a one there's a one myth going on in industry. I say your code is your context, you don't need it, and this exactly will prove wrong, because I have provided the code as a context into one place and I have used the context in the other, and you can see how different they would look like. So I got my second results and I think the change has been delivered. Yes. If you see the demo, it has gone almost 600 plus line, almost 6 times more code, and it has managed to create almost 9 files, 4 new files, and modified the file files. It modified the database, it modified the queue contracts, it also modified and produce a new permission roles. Even if we go here, these 2 sessions just completed, we can see here with the context, how does it works, where the compliance goes through, and without context, how does it looks like. So this is where the difference between the code as a context versus the actual context that we provide. Please make sure you go through this on your local machine. Remove the flag from the timeout because you might have a little bit more time to do so. Now let's go back on our original presentation. Right. So here we are on our original presentation. Same prompt, bare workspace. The exact same prompt goes into the workspace that only exposes the source. There is no GitHub behavior layer, no architectural docs, and no certain custom context files. It runs and spends most of its time on a raw TypeScript. If you go through these logs, you will find this very interesting that how much file it has read. It read almost 19 files, which is 18% of the code base. If a code base is larger, it could actually consume more tokens because the more reads means more input tokens, and very quickly it might fill your context window as well. The 5 globe search and 40 tool calls. That will generate so much input tokens, which can easily create hallucination in terms of AI models to actually lead to some undesired outcomes. It finds the code pattern, but nothing that spells out the actual contracts that we are looking for. Around 80 seconds, make a critical wrong call. So if you see that log, you'll find that when it particularly make around 80 to 90 seconds, it is likely going to make a critical wrong call. Instead of adding the side workflow in the existing module, which already exists, it plans a brand new escalation subsystem on its own. It creates the service, routes and schema and everything. The runtime times out after the 3 minutes because we set that 3-minute timeout. It produced around 34.8 kilobyte patched across 8 files. It looks substantial, but this is the hidden spec. It failed on virtually every NFR, and it only lands 4.5 as a code review. On the other hand, the prompt was identical, but the workspace now includes the context that we were anticipating. With the first 15 seconds, the agent reads the context itself and discover where exactly it needs to make changes. After reading 20 files, it produced the 14-point plan around T plus 60. and its only application.ts and load service.ts, which was exactly intended to be edited. No new routes, no new schema, and no new views. The result, just 3.1 KB batch, compact and manageable, done within the 1 minute and 24 seconds, scoring 14 out of 14 assessment criteria. The context doesn't make model smarter, it actually makes model relevant. The teams move through this maturity level, guessing the manual pasting, repo level context, and finally the context as a maintained system. These scores walk you through this progression. In this first lesson, we saw the guessing and a manual pasting. In other lessons, you start progress towards the maintained system as a context. We will curate the context, layer the instruction, plan, build, validate, and maintain. Each lessons add one piece. That's the foundation. AI-assisted coding fails without lasting context. Context engineering is how you fix it. Let's wrap up our lesson 1. Now I want to hear from you. What's the biggest challenge you're facing with AI-assisted coding in your repo right now? It is naming, architectural drift, or something entirely different. Share your thoughts, doubts, and a question in comment section below. We'll be selecting the best comments to join us for exclusive upcoming live session, so don't miss out on that event. Finally, please make sure to hit the subscribe and turn on those notifications so the next lessons reach your timeline the second they drop. Thanks for watching, and I'll see you in the lesson 2.